Welcome to the Orbit DIY channel. In this video, I am going to build a cordless screwdriver. To start, I had the main body crafted from walnut wood at a woodturning shop, where the interior was hollowed out and ergonomic finger grooves were added to the surface for a better grip. I then applied lacquer to the walnut body to give it a polished, professional finish. Initially, I planned to build an H-bridge circuit using touch modules, resistors, and transistors to control the motor's direction. I first assembled the circuit on a breadboard, connected the motor, and tested the touch modules to confirm the motor rotated in both directions. This H-bridge circuit uses 4 transistors as switches to control motor polarity. When the TTP223 touch module is touched, it sends a signal to trigger a diagonal pair of transistors. This allows current to flow through the motor in one direction. Touching the other TTP223 triggers the opposite pair, reversing the polarity and the motor's spin. The 1N4007 diodes act as flyback diodes to protect the circuit from voltage spikes. After the successful test, I moved to build a minimalist version of the H-bridge circuit small enough to fit inside the wooden body, which included the transistors, resistors, and flyback diodes. I used heat shrink tubing on the components to prevent any electrical shorts. Once the circuit was complete, I connected the gearbox motor to the center of the H-bridge and wired the VCC and ground for the touch modules. After connecting the battery and testing it, I placed the circuit inside the body. But I encountered a major issue. The wooden housing caused both touch modules to trigger simultaneously, causing the circuit to fail. I tested various insulation materials, but eventually, I decided to scrap the touch modules, disconnected the motor from the electronic H-bridge, and switched to a mechanical circuit. I chose 2 mechanical switches with 3 pins, normally open and normally closed. This setup functions as a mechanical H-bridge using 2 limit switches. Each switch has 3 pins: common, normally open, NO, and normally closed, NC. In the idle state, both motor terminals are connected to the same potential, so the motor remains off. When a switch is pressed, it toggles the connection from NC to NO, reversing the current flow through the motor and changing its direction. After wiring them according to the diagram, the motor worked perfectly in both directions. I cut a small piece from the end of the walnut wood to create my own wooden buttons. I measured the placement for the buttons on the body and drilled the holes using a 5 mm drill bit. I took the wood scrap, split it, and attached a piece to the 5 mm bit using superglue. By spinning it against sandpaper with a drill, I shaped the wood into perfect 5 mm circular buttons. To house the switches properly, I used a piece from a syringe barrel because its curved shape fits perfectly against the round interior of the wooden body. To avoid putting pressure on the switch pins, I applied hot glue and pressed the syringe casing into it to create a custom molded seat. Finally, I installed the motor and switches into the body. During assembly, I realized that an 18650 battery would not fit due to a calculation error, so I opted for a 14500 battery instead. I sanded the battery terminals slightly to ensure the solder would bond properly. I carved out a space in the wooden end cap for the charging module and drilled a small hole for the LED indicator. To make the charging light visible from the outside, I placed a thin piece of plastic over the LEDs to act as a light pipe, directing the light to the small hole next to the USB port. I placed the battery in its compartment, connected the battery and motor wires to the charging module, and tucked everything into the body. After testing to ensure the motor worked correctly, I focused on the tool head by taking a plastic wrench handle and removing its internal metal part. The handle was too long and thick, so I shortened it and thinned its diameter using a grinder while spinning it on a drill to match the motor's size. I used the internal metal part of an electrical terminal block as a coupling to connect the motor shaft to the wrench head. With everything assembled, I connected it to a charger. The red LED lit up, and after a while, it turned blue, indicating the battery was fully charged. My cordless wooden screwdriver is now ready for use, and with the interchangeable bits, I can easily tighten or loosen various screws. If you enjoyed watching this build, please like, comment, and subscribe. Thank you for watching.